Currently, the world runs on fossil-based fuels. The problem with these fuels is that they are finite and heavily contribute to global pollution by increasing the production of greenhouse gases.
There has been a lot of research done in biofuels because it promises to be a cleaner and more economical alternative. Here at the WEN Protein Assembly Engineering Lab, one of the many projects that we conduct looks into engineering different organisms to break down cellulosic biomass and convert it into usable fuels.
We, Daniel Coelho, an SROP student and a senior from the University of Miami,
and Eugene Kim, a short student and a senior from the University of Michigan,
have been working on very similar approaches to this research. We are both engineering novel protein scaffolds and cellulases for this very purpose.
So how does this work? We've enlisted some of our lab mates here to help you guys visualize what these complexes are doing. Think of them as overeducated assembly line workers.
In this analogy, our WEN Lab factory workers want to build a box, pack it with lab supplies, and tape it up. The problem is that each one of them can only do one part of the task.
Hui is the only one that can initially hold the box. Aishita is the only one that can place the flasks in the box.
And Scott is the only one that can tape the box up. In our analogy, they are each a different cellulase. They also have ADD, so they're not standing around, but wandering around much like enzymes in a solution do.
Right now, when they are wandering around with no structure, they get the job done, but haphazardly and not very efficiently. Now, Dr. Wen doesn't like inefficiency, so she ties her grad students together to make them pack boxes quicker.
What our protein scaffolds do is leash the enzymes closely together and give them order to force them to work much like an assembly line.
While our projects are similar, we are each engineering different proteins.
My proteins, on which I work with Hui, one of our graduate students, attack one type of cellulosic biomass,
while my proteins attack a different kind.
To conduct this biological engineering, we use standard techniques in molecular biology.
This included PCR reactions, heat shock transformations, expression of our proteins, and spectrophotometric and cellulosic activity assays.
The work is still ongoing, but when the organisms are completely engineered, we will move on to testing them in bioreactors.
This will allow us to see how effective our organisms are at making biofuels.
The idea is that our organisms will help in the effort to find alternative energies.
From the WEN Lab, thanks for watching.